Hello everyone, good morning. So your first exam will be on October 7th on Thursday. So we'll talk about the exam first and then we'll go to our regular lecture. Okay, so your first exam will cover chapter 1 to chapter 6, but we didn't cover chapter 5, right? Sorry, I think we didn't cover chapter 4. So that's mean your first exam will cover chapter 1, 2, 3, 5 and 6. And your exam will be also online exam. So I'll post the exam on MyLab Statistics, Pearson MyLab Statistics. And I will give you 24 hours window. So that's mean your exam will open on Thursday, 12 a.m. So October 7.
Hold up.
So exam 1, okay, so let me, okay. And we'll have 24 hours window. So that's mean the exam will open at 12 a.m. and close at 11:59 p.m. And it will cover chapter 1, chapter 2. So it will cover chapter 1, 2, 3, 5, and 6. And you'll have total 25 questions. So 15 multiple choice questions and 10 short responses. No, you will not have any class on Thursday. On the exam day, you will not have any class. So I have already posted the review problems on MyLab Statistics. So if you log into MyLab Statistics, you will see the review problems for the first exam. I think there are total 49 problems, maybe. Do you have any question about the exam?
Is it proctored? Like, are we using Respondus Lockdown browser or Proctorio?
No, it is not proctored, but it is timed exam. So that's mean you will have, I think I'll give you 1 hour and 30 minutes. So once you start the exam, you have to finish it within 1 hour and 30 minutes.
Okay, thank you.
You're welcome. Yes, the exam will be similar to the review problems, but you shouldn't expect exactly the same question in the exam, but the problems will be similar to the review problems. Yeah. So there will be total 25 questions. 20 to 25 questions. I didn't make the exam yet, so yeah. So there will be, I'm planning to give you 15 multiple choice questions and 10 short responses. Total 25 questions. And the next 2 classes will be review class. So that's mean we'll go over the review problems in the next 2 classes. Okay, so I have already posted the review problems on MyLab Statistics. So this is optional. But if you solve the review problems, I might use your answer or your responses for giving you some extra credits. Yeah. I'll also email about the email the exam details. Any other question?
Did you say if the exam is going to be timed?
Yes, it will be timed 1 hour and 30 minutes. So that's mean if once you start the exam, you have to complete it by 1 hour, within 1 hour and 30 minutes. Any other question? Okay. So today we'll start a new chapter. This is chapter 7, and this is about sampling distribution of the sample mean. So sample mean is a statistic. So when we construct a distribution for a statistics, that's called sampling distribution. So that's mean X bar is the sample mean, which is a statistic, and S is the standard deviation. This is also another statistic, and median is also another statistic. So that's mean this comes from the sample. So X bar is a statistic. So if we construct a distribution for X bar, that will be called sampling distribution of the sample mean. If we construct a distribution for sample standard deviation, that will be called the sampling distribution of the sample standard deviation. And if we construct a distribution for the median, then that will be called the sampling distribution of the sample median. Yeah, but we'll only cover the sampling distribution of the sample mean. In this course, we'll just cover the sampling distribution for X bar. We are not going to discuss the sampling distribution for S, median, or range, or any other statistics. Okay, so before going to the sampling distribution, first we need to discuss about sampling error. So what is sampling error? Sampling error is the error resulting from using a sample to estimate a population characteristic. So we already know there are two types of statistics: descriptive statistics and inferential statistics. Okay, so descriptive statistics is the measurements which are related to the sample. These are called the quantitative sample. Variable. These are called the descriptive statistics, or the measurements which are related to the sample. And parameters, that's mean the measurements which are related to the population are called parameters. For example, the mean of the population is mu, which is a parameter, and sigma is the standard deviation of the population, which is also another parameter. Okay, first, we do not know the value of mu, and usually we do not know the value of mu and sigma. So what do? We collect a sample from the population and we calculate the mean for that sample, and which is X bar, and we use this value, this statistic, to make inference about the population parameter. So that's mean we calculate X bar and we use this value to make inference about mu. And similarly, we calculate the sample standard deviation and we use this and to make inference about sigma. Okay, so now the problem is here. So we can collect different samples from population, right? So we can collect many samples from population with different sample size, right? Okay, so this value is not equal to mu. It could be different from mu, right? For different sample, we'll have different X bar. So for example, if we have in our population, we have 3 or 4 values in our population. For example, if we have 15, 20, 23, and 10. So if this is our population, and if we collect a sample of size 2, then we can collect a different sample from this population. For example, we can consider 10 and 15, right? Sample size 2. So this is one sample. So we can also take 10 and 20. So this is another sample. And similarly, we can consider 20 and 23. This is another sample of size 2. And the sample mean for this one is 12.5. And the sample mean for this one is 15. And the sample mean for this one is 11.5. Now you can see that for different sample, we have different sample mean. So that's mean when we use X bar, but mu is fixed, right? If you calculate the mean for these 4 values, then the mean is 10 plus 15, 25 plus 20 is 45. Oh, sorry, 30. Yeah, 25 plus 20 is 45. Plus 23 is 48. 68 divided by 4. So this is 17. So the population mean mu is 70 is equal mu. But if you consider different sample from here, then you can see that the sample means for this one is 12.5 for the first one. So X bar for the first sample is 12.5. So if we use this value to estimate 17, then you can see that this is different from 17, right? But we are using this value to estimate 17. So that's mean we have some error. And similarly, if you use this sample 10 and 20, so the sample mean will be then 15. So this is also different from 17, right? So there is also some error. And similarly, if you use 20 and 23, then the sample mean it will be then 21.5. This is also different from 17. So that's mean if we use the sample mean to estimate the population mean, there will be some error. This error is called sampling error, because this error occurred because of sampling, because we considered different samples and calculated the mean and using that mean to estimate mu. So because of this sampling, different sampling, we have some error, and this error is called sampling error. Okay, so here the sample statistics are used to estimate population parameters. Example, X bar is an estimate of the population mean mu. The problem is different samples provide different estimates of the population parameter. That's what we discussed. And sample results have potential variability, thus sampling error exists. Okay, so now the question is, how do we calculate the sampling error? The sampling error is the difference between a value, a statistic computed from a sample. So we calculate the mean from the sample, that is a statistic. So the sampling error is the difference between the statistic and the parameter value, the actual parameter value. So for mean, the parameter value is mu, and the sample statistic is X bar. So that's mean the sampling error in this case will be the difference between these two numbers. So that's mean X bar minus mu. So the sampling error for the mean is X bar minus mu, where X bar is the sample mean and mu is the population mean. Okay, so if we review the definition of population mean and sample mean, then you can see that population mean mu is equals to sigma of xi, that's mean summation of xi divided by the population size. That's mean all the observations in the population. And X bar sample mean is the summation of xi divided by sample size n, where n is the sample size and capital N is the population size. Okay, so now I'll go over an example. If the population mean is mu is equal 98.6, so we are given that mu is 98.6. A sample of n equals to 5 temperatures. So the population is that here The variable is temperature, and the population mean is 98.6 degrees, and the sample of n equals to 5. So here the sample size is 5. Here's a sample mean of x bar, which is, so the sample mean is 99.2. So we have the population mean is 98.6 and sample mean is 99.2. Then the sampling error, we have a sampling error, right? Because the population mean is 98.6 and the x bar is 99.2. So they are different. So the sampling error will be then x bar minus mu, which is equal, actually it should be other way. So x bar is 99.2 minus 98.6, which is 0.6 degrees. So this is the sampling error. Do you have any question? Okay, so we have another example here. Thank you. Consider the following population of 6 numbers. So what is the population size here? What is big N here? This is 6, right? Yes, this is 6. Thank you. So the population size is 6. Find the population mean. So the first part is we have to find the population mean mu. So mu is equal then 16 plus 13 plus 7 plus 20 plus 9 plus 12 divided by 6. So that's mean it will be then I think it's 77 divided by 6. So it will be then so 12 point. So if you use calculator, then it will be 77 divided by 6, then it will be 12.83. So the population mean is 12.83. Yeah, thank you. It is 12.83. So part B is Lisa selected one sample of 4 numbers from this population. The sample included the numbers. So one sample is collected and the sample is 13, 7, 9, 12. Calculate the sample mean and sampling error. So part B, we have to calculate the sample mean, x bar. So x bar is 13 plus 7 plus 9 plus 12 divided by 4. So this is the sample mean. So this is 41 divided by 4. So this is 10.25. So the sample mean is 10.25. Excuse me. Yeah, thank you. It is 10.25. And population mean is 12.83. So we have a sampling error here, right? Because the sample mean is different from population mean. So the sampling error in this case will be then sampling error is 10.25 minus 12.83. So this is the sampling error. So 10.25 minus 12.83. So the error is negative 2.58. Yeah, that's correct. Thank you. So this is negative 2.58. Okay, so let me save your responses. Okay, thank you. The next problem is consider the following population of 10 numbers. So we have 10 numbers. So we have to find the population mean. This is actually similar problems. So we have to first find the population mean. Mu is equal 20 plus 18 plus 13. So you have to add them together. So first number is 20 plus 18 plus 13 plus 12 plus 9 plus 5 plus 11 plus 7 plus 8 plus 30. So this is 133. So if you add them together, it will be then 133 divided by 10. So that's when it will be 13.3. Okay, so now part B, a sample is collected and the sample size is 2, 4, 6, 8, 9. So the sample is collected and it has the sample size 9. So that's mean X bar will be then, so we have 133 minus 12. So if we add them together, then it will be then 121 divided by 9. So this is 13.44. So this is the sample. Yeah, 13.44. Thank you. You got the correct answer. So now we have to calculate the sampling error. So in this case, the sampling error is equal X bar minus mu. So that's mean 13.44 minus, oh, I'm sorry. Yeah, 13.44 minus 13.3. So it will be then 0.14. Yeah, that's correct. So the answer will be then 0.14. So this is the sampling error. Okay, so now you know the sampling error and the sample mean and the population mean and what is the sampling error. Okay, so now we'll discuss about the sampling distribution of the sample mean. So that's mean if we have, for example, if we have 4 observations in a population, 4, 5, 6, and 3. So this is our population. And we have 4 observations in our population. Okay, so now we'll collect, for example, if the sample size is n is equals to 2 or n equal 3, maybe, yeah, let's consider n equal 3. Okay, so our sample size n equal 3. So now we can collect a different sample from this population, right? So if we consider without replacement, that means once you collected the numbers, you are not going to replace it. Then we'll have how many possible samples we can have. We have total 4 numbers, right? We have total 4 numbers. So if we collect 3 numbers from this 4 number, then we can have different type of sample. We can have 4, 5, 6. This is one possibility. Or we can have 4, 5, 3. Or we can have 4, 6, 3. Or we can also have this sample 5, 6, 3. Yeah, these are the possibilities. So if you consider 3 numbers from these 4 numbers, then we have these possibilities. So this is sample 1, this is sample 2, this is sample 3. So the first one is sample 1, this is 2, sorry, this is 2, this is sample 3, and this is sample 4. So we have total 4 samples. So if we collect a sample with size 3, from this population, then we can have 4 samples. Okay, so from these 4 samples, we can calculate 4 different sample mean, right? So calculate the sample mean for the first one, then it will be 4, 6 plus 5. So that's mean 15 divided by 3. So it will be 5. And this one will be 12 divided by 3. So that's mean 4. And this one will be 13 divided by 3. That's mean it will be 13 divided by 3. So that's mean 4.33, I guess. Yeah, 4.33. Yes, that's correct. And this one will be 11 plus 3, 14 divided by 4. So it will be also 4.67. Yeah, 4.67, I think. That's correct. Thank you. Yeah. Okay, so now we have 4 different sample means, right? Now, if we consider each sample mean as an observation, then we will have actually 5, 4, 4.33, 4.67, right? So now if we construct a distribution for these 4 numbers, so that will be called the sampling distribution for sample mean X bar. So that's mean the sampling distribution means you will collect all possible samples from the population. And here we are talking about the sampling distribution for mean. So that's mean then you will calculate sample mean from each sample. And you will have different numbers. Consider those numbers as a new population and construct the distribution for that population. That distribution will be called the sampling distribution for the sample mean. Our original distribution was this one. This was our original population. Now we have new population. So for this population, we have a distribution, and that distribution will be called the sampling distribution. Do you have any question? Is it clear what is sampling distribution? Okay, great. Thank you. Okay. So let's go over another example. So this example actually comes from the previous chapter, and this is about the heights of 5 basketball players. So we have 5 basketball players, A, B, C, D, E. We have 5 players, A, B, C, D, E, and this is our population. And we know the heights of these 5 players. So height of A is 76, and height of B is 78, and height of the player C is 79, and height of the player D is 81, and height of the player E is 86. So now the sample size is 2. So we'll construct a sampling distribution for X bar. So first collect all the possible samples with size 2. So that's mean you will choose 2 players from this population and you will collect all the possible samples. So what are the possible samples? With A, we can have A, B, A, C, A, D, A, E, right? So with A, we can have these 4 samples. Then start with B, B, C, B, D, B, E. So we can have these 3 samples with B. Then start with C, C, D, C, E. Then we can have these 2 samples with C. Then D, E. So these are the possible samples. Okay, so now write down the corresponding heights. So height of A and height of B, then height of A and height of player C, and so on. Then calculate the sample mean. The sample mean is this one 77. For this one 77.5, 78.5. Okay, so now we have this number of observations. how many observations we do have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. Let's consider these 10 observations as a new population. And if you construct the distribution with these observations, that will be called the sampling distribution for X bar, where sample size is 2. Okay, now we'll construct the sampling distribution with different sample size. We'll use the same example and we'll construct sampling distribution with different sample size. So dot plot for the sampling distribution, and we use dot plot to construct the sampling distribution. So first we started with sample size 2. So we have total 10 observations and the population mean mu was 80. So this is the distribution for when n equals to 2. So now we have 5 different sampling distribution. First one is sample size with sample size 1, then sample size 2, sample size 3, sample size 4, and sample size 5. So we have 5 sampling distribution for sample mean. So now if you compare these 5 distribution, you can see that for the first one, the sample mean is not equal to the population mean. But here the sample mean, the population mean is 80. And only for this one, and this one, we have the sample mean is equal to the population mean. But for the other two, they are not equal. So that's when we have sampling error, right? So when we will use X bar as the to make inference about mu, then we'll have sampling error. And you can see that clearly we have sampling error here, right? Yeah. Okay, so one more thing here we can observe. So when the sample size is 5, that means that's equal to the population size. So that means we are considering all the observations in our sample. So we have just one sample. And if you calculate the sample mean, then we have the sample mean is 80. We have just one sample. If you consider the sample size 4, then we'll have 5 samples. And you can see that we have 5 sample mean. This is sample X bar, this is X bar, this is also X bar, this is also X bar, this is also X bar, when sample size is 4. Okay, so we have 5 samples, that's why we have 5 sample mean. And this is the distribution for X bar when n equals 4. And this is the distribution for X bar when n is 5. And this is the distribution for X bar when n is 3. And this is the distribution for X bar when n is 2. And this is the distribution for X bar when n is 1. Okay, so what do you see from this distribution? The distribution of X bar for different sample size. So what's happening here? If you see, if we increase the sample size, when n equals to 5, the sample mean exactly equal to the population mean, right? So that's when there is no sampling error. When the population size and sample size is same, that's when we are considering the actual population as our sample. So that's mean in that case, there is no sampling error. When n equals 4, we have sampling error, but what do you think? The sampling error is less than the sampling error for n equals to 3 or more than the sampling error for n equals to 3. So if you compare the sampling error for this one and this one, which one has less sampling error? When n3 or n equals to 4? What do you think? Anyone? Yes, n equals 4. So when the sample size is n equals 4, we have less sampling error. So that means if you see the pattern, you can see that when n is 1, this one has the largest sampling error, right? I think this one has the largest sampling error. When n equals 2, yeah, this is from here to here. So I think this one has a smaller sampling error compared to this one. And if you compare this one with this one has a smaller sampling error compared to this one. And if you compare this one, then you can see that this one has a smaller sampling error compared to this one. That means if you increase the sample size, it will reduce the sampling error. And that makes sense actually. So for example, if in our class we have total 134 students. So if we want to know the test average of this class, but we do not want to collect the grade from each student, we just want to take a sample from the class. So if we consider 10 students from the class, and if we collect the grade from that 10 students and calculate the average. So if we use that average, and in another situation, if we collect grade from 50 students. So in the first scenario, we collected grade from 10 students. And in the second scenario, we collected grade from 50 students. We calculate the sample mean for this one and also sample mean for this one. That means the average grade from 50 students and the average grade from 10 students. I think the average grade for 50 students, that will better represents the class grade compared to the average for 10 students, right? Yeah, so that's why when we increase the sample size, the sampling error decreases or reduces. Yeah, sample size and sampling error. The larger the sample size, the smaller the sampling error tends to be in estimating a population mean by a sample mean X bar. So that's mean when we will estimate a population mean mu by a sample mean X bar, if you increase the sample size, then the sampling error tends to be, so the sampling error will decrease, or the smaller sampling error tends to be. Okay, so now I'll show you a computer simulation. Okay, so just give me a second. Okay, so clear this one. Let's consider this is from Escape. Okay, so this is, oh, I'm sorry. Okay, so this is our population distribution. The first one is the population distribution. Now we will construct the sampling distribution. So the distribution of means when n equal to, so we consider the sample size equal to here. And here we consider, and we are using mean to construct the sampling distribution. And here we have the sample size 5. So now we are simulating this one for 10,000 times. And you can see this is the sampling distribution of X bar when n is 2. And this is the sampling distribution for X bar when n is 5. And you can see that when we have larger sample size, we have less variability, right? If you look at this one, this distribution has less variability compared to this distribution. And you can also see that the mean this is for this one is 8.01. And the mean for the population, this is our actual population. The first one is our actual population. And this is the sampling distribution when n equal 2. And this is the sampling distribution when n equal 5. So the actual mean for our population was 8.08, and this is the mean when n equal to, which is 8.01. So this is different from 8.08, right? And when n equal 5, this is 8.04. This is also different from 8.08, but this one is close to 8.08 compared to this one. So that's mean when sample size is larger, we have a smaller sampling error. So if you take the difference from 8.08 to 8.04, the difference is 0.04. And for this one, the difference is 0.07. So let's change the sample size. Let's consider 10 and 2 and see what happened. So we are doing 10,000 times. So we increase the sample size. Now you can see that the variability decreased, right? And the sample mean is 8.04 still, and here 8.05. Okay, so let's consider another sample size, n equals to 16, and do 10,000 times. Now here you can see that the sample mean, sorry, it has less variability, right? The variability reduced. And the sample mean for this one is 8.09, which is different from 8.08. But here n equals to 16. So we increase the sample size, and the mean is exactly equal to the population mean, 8.08 and 8.08. So let's increase the sample size again, make it 25, and do it 10,000 times. See, here most of the observations are close to 8.08. So that's mean the variability decreased or reduced. And here the mean is 8.08 and this is 8.09. They are very close. But when n equals to 2, the mean is 8.03, which is the difference between this one is larger than the difference between this one and this one. Okay, so let's go back to the PowerPoint slide. Do you have any question about sampling error and sampling distribution? Okay, thank you. Okay, so the second section is about the mean and standard deviation of the sample mean. Okay, so since the distribution of X bar is also a population, is the sampling distribution of X bar is also a distribution, so it should have a mean and a standard deviation, right? So now we'll discuss how to calculate the mean X bar and the population of, and the standard deviation of X bar. So the mean of X bar is denoted by mu X bar, and the standard deviation of X bar is denoted by sigma X bar. So mu X bar, or you can read as mu sub X bar, and this one you can read as sigma X bar or sigma sub X bar. Okay, so mean of the sample mean. So what is the mean of the sample mean? If the sample size is n, the mean of the variable X bar equals the mean of the variable under consideration. So that's mean the mean of X bar is always equal to the mean of our actual population. So mu X bar is always equal to mu. So that's mean if the sample size is n, and if you collect all possible samples from the population, all possible samples, and if you calculate the X bar and construct the distribution, then the mean for that distribution will be equal to the mean of our actual population distribution. That's mean it will be always equal to mu if you consider all possible samples. So now I will show you how do we calculate this. So we know that X bar is equal sigma of xi over n, right? So we know this definition where I is equals to 1 to n. Or you can also write this one as 1 over n summation of x1 plus x2 up to xn. Okay, so what is the expected value of x? This is mu, right? The population mean is the expected value of x. So how many x we have here? We have nx. So that's mean the expected value, if all these observations come from the same distribution, that's mean come from the distribution with mean mu, then the expected value of x1 will be also mu. The expected value of x2 is also mu. They came from the same distribution with mean mu and variance sigma square. And xn is also mu. So now we'll calculate the mean of x bar. So mean of x bar will be then expected value of x bar, which is expected value of 1 over n and x1 plus x2 plus up to xn. So that's mean we can take out 1 over n, then it will be expected value of x1 plus expected value of x2 plus expected value of xn. We can distribute expected value to each one, and we know this property from our previous class. So I think in chapter 3 or 2 maybe. Yeah. So now we have 1 over n, and we know that the expected value of x1 is mu. So this one will be mu. The second one is also mu plus up to mu. So how many mu do we have here? We have n number of mu's. So we can just write here 1 over n, and we have n number of mu's. So if we add them together, then it will be n times mu, right? So if we cancel out this one, then it will be mu. So that's mean if the mean of the population is mu, then the mean of x bar will be also mu. Do you have any question? So that's why we have mu x bar is equal mu. So that's why we have this one. Even if you do not understand this one, that's okay, because actually I am just showing you this one so that you can have the idea, but you just need to know that mu x bar is always equal to mu. That information you need for this course. Okay, so now the standard deviation for x bar. That means sigma x bar. First calculate the variance. So if the variance v of x is sigma squared, so that's mean the population variance is sigma squared, then the variance for x bar will be sigma squared over n. So the standard deviation is the square root of sigma squared. So if you take the square root, then it will be sigma x bar. So if you take the square root of this one, then it will be square root of sigma squared divided by n. So we can separate this one, square root of sigma squared and square root of n. And finally, we'll have square root of sigma squared is sigma and divided by square root of n. So that's when the standard deviation of x bar is sigma over square root of n. That's why we have sigma x bar is sigma over square root of n. So we need these two pieces of information. If x is a distribution with mean mu and variance sigma square, then mean of x bar is also mu. and variance of x bar is sigma squared over n, and standard deviation of x bar is sigma over square root of n. So you need these two pieces of information, and we'll be using these two pieces of information in the following chapters as well, in chapter 8, 9, and 10 and 11. So that's mean these two information is very important: the mean of x bar and the standard deviation of x bar. Do you have any question? I'm not showing you how do we get this one, because you will get confused, I think, if I show this one. Okay, thank you. But you should know these two pieces of information. Okay, so now we'll go over some examples. The first one is, let x bar be the mean of a random sample of size 50. So here x bar is the sample mean, and the sample size is 50 here. From a population width mean, and the population mean mu is equals to 112, and standard deviation sigma is 40. So number one, find the mean and standard deviation of x bar. So find the mean of x bar, that's mean mu x bar, and find the standard deviation of x bar. So we already know that the mu x bar is equal mu, which is 112, and mu x bar is sigma over square root of n, and sigma is 40 square root of 50. So this is equal, so 40 over square root of n. So we can write this one as 40 divided by 5 square root of 2, or you can directly calculate it using calculator. Yeah, 40 divided by square root of 50. Okay, in part 2, find the probability of x bar as it assumes a value between 100 and 40. Okay, so I'll discuss these two later, because first I need to, before solving these two problems, I need to also talk about the distribution of x bar. Otherwise, you'll not understand these two parts. Okay, so we have one more example here. The mean and standard deviation of the tax value of all vehicles registered in a certain state are mu is equal 13,525. So this is the population mean, and the standard deviation is 4180, and the sample size is 100. So what are the mean mu x bar, and what is the standard deviation sigma x bar, and also find the sigma squared x bar. Okay, so find these three values. Okay, so find the value of mu x bar, sigma x bar, and sigma squared x bar. So what is the value of mu x bar? Anyone? Yeah, is the same, right? It's same as mu. Okay, so now find the value of sigma square x bar and sigma x bar. Yes, find the value of sigma square x bar and sigma x bar. So what is the value of sigma square x bar? Yeah, sigma, yeah, you got sigma 418, and okay, 418 is sigma x bar. Yeah, that's correct. Sigma x bar is 418. So how about sigma squared x bar? Yeah, that's correct. Sigma x bar is 418. So what is the value of this one? Yeah, this is 418. That's correct. Because this is 4180 over square root of 100. So that's mean this is 418. So what is the value of this one? Sigma square x bar. Anyone? Okay, so you got 174724, 174724, 4180, 4180 square divided by 100, 1747. Okay, so actually it should be 174724, not 1747.24. So this is sigma square over n. I think what you are doing sigma square over n square. So here whoever got 1747.24, I think you are doing sigma square over n square, but it should be sigma square divided by n. So that's mean a square of this number divided by 100. So it will be then 174724. Yeah, that should be the correct answer. Okay, thank you. So now we have another example, complete parts A through E for the population data below. So we have the population data and the population is 36912. So find the mean of the variable. So first we have to find the mean. We have to find mu. So we have 3 plus 6 plus 9 plus 12 and divided by 4. So that's mean this is 7.5. The population mean is 7.5. Yes, this is 7.5. So find the sample mean x bar for each possible sample of size n equal 1. So now we have size n equal 1. So what are the possible samples? The possible samples are, so if we draw a table, construct a table, then this is samples and this is mean, sample mean. Okay, so we have sample size 1. So we can get either 3, 6, 9 or 12. So these are the possible samples. So now if we calculate the mean, then it will be 3, 6, 9, 12. Yeah, so this is the, now you can construct the distribution of X bar. That will be the sampling distribution when n is equal 1. So for the same population, now we'll find the sample mean for each possible sample of size 2. So now we have sample size 2. So the samples will be then, and this is mean. So we can get 3, 6, 3, 9, 3, 12, right? 6, 9, 6, 12, or 9, 12. So these are the possible samples. Now if we calculate the sample mean, this is 4.5, this is 6, this will be 7.5, and this is also 7.5, and this is 10, sorry, 18, so it will be 9, and this one 21, so it will be 10.5. So these are the sample mean. So this is X bar. So these are the possible samples, and this is the sample mean. Now we can also construct the distribution for this one. Yes. Okay, so we are using the same population. Now we have sample size 3. So we'll find the all possible samples and their sample mean. So this is samples and this is mean. So we can get 3, 6, 9, 3, 6, 12, 3, 9, 12, or 6, 9, 12. So these are the possible samples. Okay, so now we have to calculate the sample mean for each one. So the sample mean for the first one is 9 plus 9, 18. So it will be 6. So this is 9 plus 12, 21. So this will be 7. This is 24. So that's mean it will be 8. So this is 15 plus 12, 27. So this one will be 9. So this is the corresponding sample mean. So now you can construct distribution for this one. Okay, so find the sample mean for X bar for each possible sample of size 4. So size 4 means the total population, and the sample mean will be, so we have just one possible samples, 3, 6, 9, and 12. So if you calculate the mean, it will be then 7.5. Okay, so here we have one more example, and this is the last example for today's class. The data table represents the ages of the winners of an award for the past 5 years. So this is the ages of the winners of an award for the first 5 years. So we have 5% and ages for that 5%. So use the data to answer questions 1 through C. Determine the following mean age mu of the 5 winners. So first you need to calculate the population mean mu, because this is our population. So we have the age 36 plus 55 plus 39 plus 38 plus 25 divided by 5. So this is 38.6. Okay, consider samples of size 2 without replacement. So we'll just consider 2 numbers, but we are not going to replace them. So what are the possibilities? So now you have to calculate all the possibilities. So since the sample size is 2, we have to find all the samples with size 2. So the possible samples could be 36, 55, 36, 39, 36, 38, 36, 25. So first I start with 36, and we have 4 possibilities. Then I start with 55, then we have 55, 39, 55, 38, 55, 25. So 55, 39, 55, 38, 55, 25. Then I start with 39. Then we have 2 possibilities. 39, 38, 39, 25. Then start with 38, we'll have 38 and 25. Yeah, so these are the possible samples. So now we'll calculate the sample mean. So the sample mean for the first one is 45.5. Then sample mean for the second sample is 37.5. So we have total 10 samples here. So that means we'll have total 10 sample means. And the 10 sample means if we can construct the distribution for this one. And that will be the distribution for X bar. And now if you calculate the mean X bar, the mean of the variable X bar, mean of the variable X bar means these are the observations for X bar. So if you calculate the mean for these values, that will be the mean for X bar. And if you calculate this one, then you will see that that is also 38.6. So that's mean mu X bar is always equal to mu. So you can calculate mu X bar directly, or you can consider all possible samples and calculate the sample mean for each one, then calculate the mean for all the means. That will be the mu X bar, and which is equal to the mu. Okay, so we have 13 more minutes. So I'm not going to start a new section today. So I'll stop here. And I'll also stay here. If you have any questions about exams, or if you have any questions from today's class, you can ask me.